Okay, so let's do another word problem. Joey made half of a recipe, one half of a recipe, and used 3/4 cups of milk. How many cups of milk are required for a whole recipe? Okay, so when you think of fractions, remember fractions are always part of a whole. It's showing you what parts we have of one whole thing. Okay, so if you think of half, it's literally half. It's divided in two. Okay, whenever you when you think of half and you have 1/2, that means that whatever parts whatever whole we have, it is divided by 2. So Joey made half of a recipe and used 3/4 cups of milk. How many cups of milk are required for a whole recipe? So upon reading this, there may be the misconception that, okay, so if Joey made half of a recipe and he used 3/4 cups of milk, okay, then all I gotta do is divide 1/2 by 3/4. Not necessarily, because you're asking you how many cups of milk are required for a whole recipe. And because remember, Joey only made half of the recipe. So if half of the recipe he used 3/4 cups of milk, how many cups do we need for one whole recipe? So if this equals out to half of the recipe yields 3/4 cup, that means that's only one part of it. We need another part to make one whole. So if we need 1/2 of the recipe, the other half of the recipe equals out to 3/4 cups. If we need to make the whole recipe, that means we need to have 2 3/4 cups. Meaning, what we need to do, we're not going to be dividing 3/4 by 1/2, we're actually going to be multiplying 3/4 times 2. Because remember, half of the recipe, and remember when I say half, that means that you are dividing something into 2 parts. Okay, those 2 parts make up that one whole. And remember with fractions, you got to think about that. When you have halves, when you have 1/4, when you have 3/4, it's making up a part of a whole. So 3/4 cups of milk yields half of the recipe, or half of the recipe you need 3/4 cups of milk. So if we want to make the whole recipe, we need to have 2 3/4 cups. So we just got to multiply it by 2. So 3/4 times 2, and if you notice, I put the 1 underneath. 3 times 2 is 6. 4 times 1 is 4. Okay, and then we can go and turn this improper. Remember, this is not simplified yet, so we gotta turn this into a mixed number. We gotta turn our improper fraction into a mixed number. So I'm gonna draw it out. Okay, so I know I'm gonna have 4 pieces, and 1, 2, 3, 4. So I know I have 4 pieces that are shaded in, but I still need 6. So that's 4, 5, 6. Okay, so I know that I have one whole at least, and then I have 2 pieces out of 4. So that is my whole, that is my mixed number. So how many cups of milk are required for a whole recipe? He's going to need 1 2/4 cups of milk. Actually, to completely simplify this, he actually needs 1 1/2 cup, because 2/4, 2 is half of 4, so it's going to be 1 1/2. When you simplify it, it's going to be 1 1/2. Okay, so now we're going to work with multiplying and dividing decimals. And so first we'll do multiplying decimals, and multiplying decimals is just the same as multiplying any other numbers, except you're having to make sure that the decimals are in the right place and you're counting the correct amount of place values. So our first problem here, 4.8 times 7.2. So I'm going to write that out. And you're going to multiply just like any other numbers. So you have 8 times 2, which is 16. 4 times 2 is 8, plus 1 is 9. Then you gotta put a 0 here. Then 7 times 8 is 56. Put the 5 here. 4 times 7 is 28. 28 plus 5 is 33. Okay, so now we gotta add those numbers together, just like any other multiplication problem. 6, 9 plus 6 is 15. Carry the 1, 4. Okay, so we have 3,456. Now, if you were to put this as the answer for this problem, that is completely wrong because there are no decimals there, and you need to make sure that you have your decimals there. So what you need to do to make sure that your decimals are in the correct spot is you need to count how many place values are in each number. So we have one number behind the decimal and one number behind this decimal. So we have 1 and 2. So we got to move our decimal 2 place values. So it's 34 and 56 hundredths, okay? Because all we had to do to make sure that the decimal's in the correct spot, we had to just count how many place values are behind the decimal. So we had 1 here in this number and 1 in this number. So it's going to be 1, 2. And that's all you have to do for multiplication. Now for a division, so let's say we're dividing a number by a whole number. Okay, so we have 7.6 or 7 and 6/10 divided by 4. Okay, so it's the same thing. You just have to make sure for division, if there's no decimal in the divisor, then you're just gonna have the decimal in the dividend, and you just got to bring the decimal up to the answer. So 4 goes into 7 one time. 1 times 4. 7 minus 4 is 3. Bring down the 6. 4 goes into 36 9 times. 9 times 4 is 36. And that's it. So our answer is 1 and 9/10 or 1.9. But it's 1 and 9/10 because I just brought the decimal up to the answer, okay, into the quotient. Now, I did not write down a number for if you're dividing a decimal by a decimal, but let's go ahead and do that right now. So let's say you're multiplying 0.25 by 5.8, or you know what, 5.5. Okay, so we need to move the decimal in the divisor. So we need to move it over to make it a whole number. So the amount of times we move this decimal, we have to move it to the right 2 times to make it a whole number. So now it's just 25. And however many times we move the decimal here, we have to move it in the dividend. So we move it over. So now we have the decimal right here. So 25 goes into 55, goes 2 times. Then 55 minus 50 is 5, and then bring down the 0. 25 goes into 55 2 times, and then 2 times 25 is 50. So we're actually left with a whole number here. So we have 22, and then we have the decimal in the back, and you could technically put 22.0, but you really don't need to. It's just 22. Okay, so let's go over integers really quick, because in the SBAC, we're actually not going to be you're not going to need to multiply, divide, subtract, or add integers. You just need to know the basic concepts of integers. So you'll be seeing a lot of number lines on the SBAC and working with absolute value and opposites. So let's do a quick review of that. So you'll see my number line here. And remember, the more left you go on the number line, the numbers get lower. The lowers have less value. The more right you go on the number line, the greater the value of the numbers. So see, as you see, it's going up. It's going 1, 2, 3, 4, 5. And that's because it's increasing in value. If the more left you go, even though you're going 1, 2, 3, 4, 5, 6, 7, 8, you're actually decreasing in value. So if you see a problem where it says, there was below sea level, which sea level would be at 0. That means that it's going to negative. So that's going to be less. It's going to be below 0. Like for temperatures, oh, it was 5 degrees below 0. If it's 5 degrees below 0, that means it's -5, which means it's going to be less than if it was just 5 degrees. Okay, so for absolute value, this is absolute value means a number that is it is the distance from 0. So the absolute value of a number is its distance from 0. Okay, so you'll see absolute value written like this, where there are two lines on the side. There's one line and another line. It's kind of making a barrier for the number or for the integer. So for this one, they're asking you, so the absolute value of -3 is however many units away it is from 0. So let's look at -3, and then let's see how many units away from 0. 1, 2, 3. Okay, so it's just 3. Absolute value of 6. How many units is it away from 0? Let's see, 1, 2, 3, 4, 5, 6. So it's 6. And absolute value is never going to be negative, because you're looking at the distance away from 0. And so, if you look at distance, distance is never negative. It's always going to be positive. So even if the absolute value is a negative number, so let's say we have like -7. So we're looking at the distance that -7 is away from 0. So let's count. 1, 2, 3, 4, 5, 6, 7. It is 7, and it is positive. Even though it is a negative number that we're looking at the absolute value of, it's always going to be positive because distance is always positive. Okay, now what about opposites? Okay, so if on the SBAC they ask you, okay, what is the opposite of 4 or -8 or any of those things? So numbers that are opposites are numbers that have the same distance away from 0. So let's say we were trying to look for the opposite of 10, positive 10. So we have our positive 10 here on the number line. So we need to look for a number that has the same distance away from 0. Okay, we know that this is 10 units away from 0. So if you look on the other side, we see that -10 also has 10 units away from 0. So 10 and -10, they are opposites because they are both 10 units away from 0. And this goes for any integer. So let's say we have, what is the opposite of -5? Okay, so -5 is 5 units away from 0. So we need to know what is the opposite of -5. What other integer, what other number has 5 units away from 0? Positive 5. They both have the same distance away from 0. So that's opposites. So it's really easy to remember if you just think, okay, well, if it's a negative number, what is the positive version of that number? If it's a positive number, what's the negative version of that number? Because negative numbers, because the negative version of the negative integer is gonna have the same distance as the positive integer. So if you have -1, it's 1 unit away from 0. If you have +1, it is 1 unit away from 0. So that's what it means to have the opposites. Okay, so now at this point, you're going to move on to the SBAC practice quiz and go ahead and work on that, and make sure that you try your best to do it without the notes. And if you do need the notes, go ahead and use the notes, but just note which ones that you were needing a lot of help on. All right.